Now that we know what radian measurements are in terms of angles, it's time to distinguish between radians and degrees, and mainly go back and forth between radians and degrees. And to do that, we're going to use something I like to call the bridge method to convert. And just to show you, imagine we have 5 miles and we want to convert that into inches. Especially if you've had chemistry, this should be something very familiar. You start with what you're given, and then you're going to make some sort of transition. So we're going to multiply by some sort of conversion factor we know. And for example, we know that 1 mile is the same as 5,280 feet, because that way the miles would cancel out, and you're left with a unit of feet. And I can go further and do another one to transfer from feet to inches. That way we get our answer in inches, and for feet it's 1 foot for every 12 inch. Because basically each one of these conversion factors is like a big number 1. So really you're multiplying by 1, which means obviously we're not changing anything in terms of the answer. So then to get your final answer here, all you would do is you would multiply the numbers across the top, multiply across the bottom, and you would divide. So when you multiply across the top, you get 316,800, and then on the bottom you would have just ones all the way across, so it's really divided by 1. So that's your answer right there. Make sure you keep your unit inches. So for this to work, we need these conversion factors here. And when we're doing between radians and degrees, we need to have that exact same idea. We need some sort of conversion factor. So if you're thinking about going around our unit circle and some things that we know in terms of that unit circle. One thing that we know for sure is that if you go all the way around the circle, that's 360 degrees. Well, that's great, but what can we combine that with in terms of radians? Well, the whole way around we said it was like a circumference, 2 pi radians. That could be a conversion factor, 360 degrees for 2 pi radians. That would be a conversion. Those are the same thing. Over here on this side would be 180 degrees, which we said was 1 pi radian. So that's another conversion factor. We can even do at the top or at the bottom. 90 degrees is the same as pi over 2. That could be another good conversion factor. Any one of these is complete fair game for you to use. I recommend this one right here just because it's the smallest numbers without getting into, like extra fractions like you have here with that pi over 2. So this right here is the one I would definitely make sure I know, and I'm going to do a lot of it. So let's get right into an example. If we want to change 2 pi over 3 radians into degrees, start by beginning with what we have, 2 pi over 3, the unit is radians. So I can write it just like that big fraction bar, 2 pi over 3. And I need to change radians into degrees. Well, if I already have radians, I need radians on the bottom so we can cancel out. And we said that it's pi radians for 180 degrees. Something else that should also very easily cancel out that you can see here is a pi. You have a pi on top and bottom, which is what you want so you can be able to cancel things out. So the pi's cancel out, that's good, and we should be able to get an answer. You do 2 times 180 and then divide it by 3 because you have the 3 on the bottom. So 2 pi over 3, when you do that multiplication, should become 120, and your unit is the degrees, just like that. Now, if we go in the other direction, we start with degrees, 225 degrees. To go in the other direction, well, we need degrees to cancel, so that means 180 degrees needs to be on the bottom, and we need the pi radians to be on top. So now, all we have is the degrees canceling out, which is good, and we're going to have something that has pi in the answer, because obviously we have pi there, it isn't canceling. Your unit is going to be radians. Now, to figure out exactly what that's going to be, well, you have just 225 on top, and you have 180 on the bottom. So 225 divided by 180 gives you 1.25. That's very improper. We can't have decimals with pi. That just looks really ugly. Notice how we have fractions with pi. So we need to somehow change this into a fraction. Well, 1 1/4, if you want to think of it that way, it's also not good to put 1 1/4 pi. So we need to change this into an improper fraction, 5 pi over 4. All right, so here's 5 for you to try. Pause the video, take a second, see if you can do all of these. Pay close attention to number 5. What unit do we have? Go ahead and give them a try. All right, let's see how these look. Give you all the answers here. The main thing to look at with number 5 is the fact that 2.1, there is no degree symbol. If there's no degree symbol, we assume that we're in radians. Okay, so that's why you have 2.1 radians. This one have to multiply by pi on the bottom for pi radians for 180 degrees on top. And this is the only time that you would ever use pi as in the answer 3.14. And actually, you should never use 3.14. You should type the entire thing into your calculator, as in using the pi button. But basically, you have 378 on top and pi on the bottom for this problem. Your unit is degrees. That's actually a more precise answer than that guy right there. But if you do type that in and divide by pi, you end up getting 120.3211 something or other, and it would tell you how you want to figure out how many decimal places. Usually it'll be 3, so it really should be 321 for your decimal. But this right here is actually the more appropriate and definitely the more accurate answer. So there's how you convert back and forth between radians and degrees.